All right, so this is the AP exam prep video. This is for 2021, and I just want to share with you and my students here about some of the things that you're going to need to know and things that you're going to be responsible for on the exam. First off, the 2021 exam is a full content exam. We are still in the throes of COVID and all that. Last year they had cut a unit, I believe, 1.5 units, 2 units. So this is a full content exam, all the units. And there's no formula sheet provided, okay? So you cannot bring in a Q sheet, or there's no formula sheets they're going to give you. You're going to have all of your common integrals and derivatives and different whatever trig identities or whatever you might need to know. You need to know what a cosecant is. You need to have that memorized. So you're going to have to study a little bit extra for this exam to memorize and commit to memory some of the volume formulas or area formulas and stuff like that. All right, graphing calculator. This is where we're at with my class here a few seconds ago. So we're going to need to know where all the regular functions on the calculator are, and of course regular functions, all the multiplication and division and all that sort of stuff over here. Also converting to fractions. You might need that. Cube root or nth root stuff. What else? What else did I say we need? Oh, over here, absolute value, right? This is absolute value, math, cursor over to absolute value. Things like that, right? Here is your y equals. This is your where you plot and stuff like that. So a TI-83, TI-84, those are the popular calculators and calculators you're probably going to be using for the exam. I don't believe that you're allowed to have a scientific calculator into the exam. It must be only an approved calculator like this, graphing type. Don't quote me on that, but I believe that that's what I recently heard, that you can't have a scientific. Not for the AP Calculus exam anyways. All right, so the other thing I was just talking about here was if you type in a function, this is your variable, of course, and if you type this function in, and if you want to get back to a standard window in your graph, it's like zoom 5 or zoom 6, right? So that gets you to a 10 by 10 by 10 by 10. Now, this graph is not showing up, so you have to understand that, this is a parabola, opens upward, and the y-intercept is way up at positive 55. So you're going to have to be able to adjust your windows. You can zoom out if you want, but then everything gets really small. So adjusting your windows is important to know. You want to increase the y-axis on your screen. So I'm going to cursor down to y max, and I'm going to go like 85 or something. Then I hit graph. You see how I have way more of the y-axis showing, and there's my graph there. Okay. What else will you need to know? You'll need to know how to find intersection points between graphs. You'll need to find maximum and minimum values. That's going to be, you might want to do that as well. So let's just say, let me just move this over a little bit or whatever okay. So this is going to change the graph just a little bit. So if I want to find the minimum value, okay, I go to the calculate menu. That's second function trace. This calculate menu has many of the things you're going to need this graphing calculator for. Calculate menu right here. And so I want to go to minimum. Okay, so you can actually get the calculator to calculate a minimum for you. You can use the cursor to cursor left for the left boundary, hit enter, or you can just plug in a value. I want to say x equals 1 is my right bound, and there it is. See, it pops over there. And then you just hit enter, and it will show you the point, okay, negative 0.499, that's negative 0.5, and 54.5. That's the minimum. That's your local minimum there, okay? So you're going to need to know how to do that. Let's say that we have another, so let's say we have 5x, okay, plus 58. Let's say we have a line like this, and I want to find intersection points. That's another main thing that you're going to have to find, and on this document that I will have up on my website here for you as well. Intersection right here, number 5. See, number 5. So you go to second function, trace, that's the calculate menu, number 5, okay? So here, first curve. See, it'll ask you for first curve, and it'll show you this is the parabola. The cursor is also blinking on the curve. You can see it clearly there. You say yes, first curve. And then it'll pop down to the second curve that you've listed in your y equals. And is that the second curve? Yes. And so do you want to guess? Now there's 2 intersection points. So you should move your cursor close to the intersection point that you want to calculate, because it doesn't know which one you want. So I'm going to put my cursor pretty much to right on that and hit guess. And it will tell me there's my exact intersection point. So on the AP Calculus exam, which I'll get to in a moment, You will have to use exact values for like finding area between a curve, let's say, or to find a cross-sectional solid or a volume of solid of revolution. You're going to have to find those exact limits of integration, things like that. So you're going to have to use full decimals. Now, again, I will get into decimals. At least three have to be shown on the AP exam. And when you're doing your calculations, as many as possible to get the accurate, precise, accurate answer. Okay, so that's a few things there. Also, derivatives. Okay, so let's go back here. Let's focus on just the one. Okay, clear. I'm going to clear that. I'm going to go to second function trace and look at this. Number six. Number 6 is dy dx. Okay, so it's gonna show this graph and it's going to ask me. Oh, wait a minute. I have to do that again. Number 6. Okay, well, I'm going to type in the value. Let's say I want to know what the value of the derivative is at x equals 1. So I'm going to put x equals 1 here, and I simply hit enter, and it'll show me the value of the derivative. So that is the value of the slope of the tangent line. Okay, that may come in handy. You'll have to know how to do that. All right, that's derivatives. There is a way I think that you can draw a tangent line as well. That escapes me right now, but draw. So there's draw there. Line. Oh, tangent. Here we go. Tangent, number 5. Okay, I can't really remember how to do this one, but let's say I want to go x equals 1. Will it do? Yeah, it'll do it right there. So there we go. And it'll give you, look at that. So it'll give you actually the equation for the tangent line at whatever x value you choose. Okay? So that's great. That's really great. And notice that at x equals 1, the slope of this tangent line is 6. And we just found that the derivative was 6. Okay? For my online class here that's listening to this lecture live, please chat in if you have any questions. I will pause and I can stop and answer any question you want. But I'm going to move on here to integrals. So what about an integral? Okay, so if I want the integral underneath this curve, let's say, and again, this is all starting from the graph. You've got things graphed. So I want to go from 1.5 as a lower limit of integration to, let's say, 2.5. And I hit enter, and look what it'll show. It'll show the area underneath the parabola curve, and it'll also give me the value of the integral. Now this is going to be really important for some free response questions in the AP exam, which I'm going to show you as well in this kind of long review lesson, I guess. But you'll need to know how to do that with your graphing technology. Okay? All right, and I do have pictures down here of different things that I've done. So the derivative, also the tangent line, right, which I've shown there as well. Integrals, okay? Now, the other thing here, if you don't want to graph the graph first, if you just want to find the value of an integral on your home screen on the calculator, you can do that too, and that's going to involve the finint function. So I'm going to quit this here, and I'm going to go to math, and then I'm going to go to number 9, finint, okay? Function integral, okay? Now, you don't have to have this graphed. You can simply put in, okay, watch this. I'm going to do the 2x squared, right? Oh, whoops. I don't know if that would work. 2x squared, I don't think, 2x times x, that might work. That's 2x squared. Plus, what did I do? 2x? Can't remember what I exactly put there. Plus 55. I think that was my function that I had. Now, what you do here from this screen is you have to basically say now, this is like the integral sign, okay? Here's the function. Now you have to put like dx. How you do that is just put comma x. So that's how you show it, or you tell it it's dx, okay? So integral of this dx, comma again, now you put in your limits of integration. So I want to do 1.5 as my lower limit, comma 2.5 as my upper limit. Now, that should work. Okay, so here we go. So that is the value of the integral, the definite integral, because it's a number here. And I think I don't know if it's, I don't know if it's still showing. Okay, so anyways, if I use the exact same, which I did, so that should have been the same as the integral from before. Okay? All right. And I believe that the end deriv and all that sort of stuff, you can do the same way. Function max, function min, all the same way. Use your commas. and all that sort of stuff. Okay, so yeah, that's the core values there of the calculator. Okay. Now this is just a little bit of a document here on calculator use. So again, some things from my webinar that I took in the other day. Plot the graph of the function with an arbitrary viewing window. Adjust your windows. Find zeros. Oh, zeros are the intercepts, right? Zeros are, zeros are 0 on the calculate menu. 0. Approximate a derivative. Approximate a definite integral. Okay, we did all those. Now here's some things though. Okay, on calculator enabled questions on the AP exam, you are permitted a calculator, so you don't have to show manual integration. Let's say you can use your calculator like this right here. You can use your calculator to show you integral. But, okay, very important, cannot forget this. If you use your calculator to solve an equation or to compute a numerical derivative or integral, you need to be sure to write the equation or the derivative or the integral first. And I will show you an example of that a little bit later on. Okay. If you use decimal approximations, you will be scored on your accuracy. So unless otherwise specified, your final answer should be accurate to 3 decimal places. Okay. So if you're going to rewrite this answer right here above, don't put 5.3. 5.333. Okay. You must write it that way. Okay. Yeah, let me see what else from this. So this was another screenshot that I took from this webinar. It was excellent, by the way. And here's some examples of a few things that we had just talked about, actually. So this is an example of a free response question, right? And in this question, they give you the intersection points of 0, 2, and 2, 4, but they don't give you this intersection point. So if you were asked to find one of these two regions, like S, or if you were asked to find the volume of a solid of cross sections that were, the difference between R and S, or sorry, the difference between the upper function and the lower function, you would need to know what this intersection point is. So you get on your calculator, you type this in, and you type this in, and you find intersection, okay? And you find out what the x value of this point is. That's going to provide your, at least one of your limits of integration. So here, notice that here's the full decimals of the intersection point. You might say, oh, that looks to be halfway between 0 and 2, so that's a 1 something. Well, you have to be exact, okay? You can't just assume it's 1. All right. And if you're going to approximate the definite integral, notice here there's 3 decimal places in this answer. Okay? And of course, this is how you would show, and you're going to have to show the integral, if you're allowed to use your calculator to find the base, the volume. Okay, so region S is the base of a solid whose cross sections are perpendicular squares, okay, to the x-axis. So that's the squares. And if you're asked to find that, you have to show the integral in the question. So you do have to write this out, not just your answer, okay? The volume is represented by this integral, and make sure you use your numbers there from here to here. Show this. Now you don't have to write out, this is another important point, you do not have to write out the entire function description. You can write just f of x minus g of x. That's important, because if you mess up, if you write this incorrectly, A, you might get the wrong answer, but B, you're showing something that's incorrect and they could dock you marks on that. Okay, so you can just write f of x minus g of x, knowing that they're already stated in the question. Okay, so this is calculator enabled questions, and there's a few tips. And trust me, when I heard from this exam reader herself, she said that we are looking for these specific things, right? The number of decimal places, the fact that you show your that you show your work, that you show your integral that you're actually solving with the calculator. So these are important. You don't have to give any extra, but no less either. Okay, so how you guys doing? Doing okay? We're motoring through here. I know this is going to be a little bit of a longer lesson, but this is a full prep for AP exam, and you're going to be happy, I think, when we get through this, because there's some really important points here. Something to have a heads up, okay? So let's say you're doing this multiple choice question, okay? And you're finding the derivative here implicitly. This is implicit differentiation. And you come up with this right here. Oh, you come up with this right here. All right? And I know this is probably doesn't need to be mentioned, but if you stop here and you say, oh my goodness, I've done something wrong because I don't see my answer there. Well, what you have to understand is that it could be that if you factor a -1 out, and factor a -1 out from the bottom as well, that actually changes the way this looks, and then that is a match, okay? So, you know what I mean? Like -5 over 2, that's the same as negative of 5 over 2, right? It's also the same as 5 over -2. Those are all the same, and that's fine. But you have to realize that, hey, you might not be wrong. You might just have a negative version of the top of the numerator and a negative version of the denominator. Okay? So just a heads up there. Another thing is that, okay, on your short answer, for sure, you need to show your work. Okay, that's fitting to get the correct answer. So you'll need to show your work, show your steps. All right. Another thing that I was going to say, I think this is mentioned later on, but when you're working out, I'm pretty sure this is mentioned later on. When you're working out your answers for your free response questions, those are the short answer questions. If you come up with something like this, -5, -5 plus x over, 2 over 5. Now, you can leave your answer like that. You don't have to evaluate. You don't have to simplify like, you've been learning in high school the whole time. You can leave your answer in unsimplified form. If it's just algebraic unsimplified form, you can actually leave your answer that way. And this is not okay in high school, right? Fractions in fraction. But if you have, like 5 root 2 over, 2 root 2, and you leave it like that, that's actually just 5 over 2. But if you leave it like that, and this is leading to the absolute correct answer of 5 over 2 that normally you would write, this is fine. Okay? So you do not have to simplify simple algebraic simplifications for fractions and things. So that's different, right, from the AP exam. Okay. All right, so with free response questions, now FRQs are free response questions, okay? And there are a few things that this reader mentioned as well. Accumulation, okay, so accumulation type questions, which are, if you have rates of, let's say, bees entering a beehive, you have a rate, okay, that this is the rate that they're coming in, and there's another rate where they're leaving, and you have to combine those in some way to find out how many bees there were in that hive from this time to this time. So you have to, it's a very popular type question, right? And which would involve integrals, right? So you take the integral of the rate coming in minus the integral of the rate going out, because the integral of a rate is the actual number of things, the definite integral of a rate. So between time A and time B. So that kind of question is very popular, and if you're in my class, we're going to go over questions like that for sure. What else? Yeah, rate in, rate out. Okay, area, volume questions she mentioned were also volumes of revolution or volumes of cross-sectional solids or that kind of thing. Even related rates questions, right? Volume of a tank of water, it's draining, related rates, remember that? Particle motion along the line, so if you have something that's traveling this way and then it's traveling that way, forward rate, reverse rate, that kind of thing. Those are popular questions as well. I don't believe that I just had a question come in the chat line. I don't believe that for multiple choice you do have to show any work. Don't quote me on that, but as far as I know, it's just a bubble form. But I'll get back to you on that as well, because I don't think they take your work into consideration for multiple choice, but I could be wrong, because she seemed to say on this webinar that that you should show this kind of work, and it was on a multiple choice question. So I don't know. I will double check on that for you though. Free response questions, okay. There will be 2 that are calculator active questions, so that means that you'll need the graphing calculator to help you, figure out this crazy integral or whatever. And there are 4 where there's no calculator involved. Okay, so what's going to happen is you're going to get the 2 with the calculator, and you're going to get a certain amount of time to do those, maybe 15 minutes each. Okay, a half an hour to do the 2. Then you will be called to stop, to put down your calculators, and move on to the next section. Well, here's the thing. You have 4 where there's no calculator allowed, but once you start those 4, you could actually go back if you had to and finish 1 and 2, but you just don't have a calculator to finish. You get it? Now, if you have to go back and finish 1 and 2 and you've got significant work to do, you're not going to get done all the 4 in the time you're given. But I should mention too that during the AP exam, you do have to keep going. You cannot get stuck on a question and just sit there for 10 minutes on a question and be stuck for 10 minutes. That is not allowed, because you're going to miss 3 other or 4 other questions, okay, that you're not even going to see. So you do have to kind of keep moving on, judge your time accordingly, and yeah, time will be a bit of a pressure because there's a lot to think about in these questions. All right, so here's the major calculus topics on the free response questions. Again, I said the accumulation, area volume. Graphical analysis, those are the types of questions where you're given a graph, right, of like, here's the derivative of g of x, this graph, you know, how far did Jimmy go when he drove, blah, blah, blah. So they give you a graph, and you have to either, you know, take the area under the curve if it's something you have to integrate, or you have to look at the slope of the tangent of that line, or so graphical analysis, maybe even slope fields and stuff like that, right? We have to look at a slope field. So you're given a graph, or you're given a table. There will be questions as you see below here. Usually there's free response questions. One has a graph, one has a table. And again, you should have seen some examples of those already, which we will go over in the next week and a half for the exam too. Usually 1 or 2 contextual questions, okay? So like word problems where there's not a graph given, but it's more in context, the word described, I guess. Okay? All right, so here's an example of the rate in, rate out question, and this particular exam reader was quite taken with this question, because I think this was a question that she actually had a hand in putting on the test, so she was really excited about this question. She's like, this is a wonderful, beautiful question she's going on. Anyways, you might not think so, but okay, so here's the type of question, right? A certain grocery store opens, 50 pounds of banana is on display. Boom. We start with 50 pounds of bananas. We know that right away. Customers remove the bananas from the display at this rate. So f of t, this would be a rate. So this is equal to the derivative, right? It's a rate of change. So this is the rate of removal, okay, of the bananas. T hours after the store opened, okay, after the store has been open for 3 hours, store employees add bananas to the table. So this is the rate of the bananas coming onto the table. But notice that rate doesn't kick in till 3 hours after opening. All of this stuff you have to jot down, put in your memory banks in order to solve questions like this. Now, the goal of this video and this lesson here is not to go over each question individually, but instead to give you tips. So I am going to fast forward here to the solution part. And I'm going to have this graphic up, but I'm also going to read from my notes below. So what are some things that are important to note about here? First of all, rates are derivatives, as I mentioned. What are we trying to calculate? The accumulation of pounds of bananas. They're not asking you for a rate. They're asking you for the amount of bananas. So the amount of something would be the integral of the rate of change of that something. Okay, the integral. Because here's the amount of bananas. And let's say you picture this as the rate down here. You take the derivative, you go to the rate. So if you're given the rate, you got to integrate to get the number of bananas. Okay? So we're popping between derivative and regular old function. A definite integral. Okay, so if this is a calculator active question, you'll have to write your integral out. Okay, so here we go. Write the integral out. You do not have to write the actual f of t function. Just write f of t. You will need, though, to show your limits of integration properly. So for the first question, this is how many pounds of bananas were removed from the display the first 2 hours. So we have a rate, so we need to find an integral. So you need to show your integral, proper limits of integration, and then if you use your calculator, then show at least 3 decimal places. You should show the whole thing, okay, write down the whole thing, and your answer is 3 decimal places. Also, if it's a word problem, you should write a word response, okay? So be clear on what if you just left this number here, they don't, you have to be complete in your correspondence with them on what this actually represents. Don't assume they know anything. So 20.051 pounds of bananas are removed from the display during the first 2 hours. Okay? Don't write a novel. Make it quick. I've seen examples of tests, and it's just really quick. 2.051 pounds bananas removed. Done. Don't say from the display that was situated by the door at Al's Banana Shop. You don't have time for that. So, but do some kind of like word sentence. All right. Whoa, big. Oh, she did say something about you can save integrals on the TI. I have no idea about that, to be honest with you. So we're going to look into that. If you can actually save your integrals, so you don't have to retype it all every time. I mean, you can put them on the y equals, right, in that screen. You can put them there. So in that sense, they're saved. You know, when you type them, and you put them in here. So in that sense, they're saved. I'm not sure if that's what she was meaning. Okay. Okay, so B, the derivative at a point. This particular question, B said find f prime of 7. So the derivative at a point, f prime of 7, and using correct units, explain the meaning. So we actually have the derivative of a rate. The derivative of the rate. So that's the rate of change of the rate. How is the rate changing? Okay. So at 1 point, so you get 1 point value for a complete explanation of this, of the meaning of this. So a sentence, reference to 7 hours, reference to rate, state the negative. Okay. Also your units, all required for the full point. So let's take a look at that. All right, f prime of 7, you find the derivative of that function. And it says this, after the store has been open 7 hours, the rate at which the bananas are being removed from the display is decreasing. So it's the rate of the rate by 8.120 pounds per hour per hour. Okay. A note here, I think that they accept, it seems like they accept truncated values too. So you know how if you round incorrectly, you know what I mean, that's a problem when you round to 3 decimal places. If you just write the 3 decimal places, I think they're okay with that too. Okay. So again, if you're not rounding correctly to the thousandth of a, rate of banana removal, then that's okay. Truncating is just writing the first 3 numbers after the decimal place. Rounding would actually be changing the numbers so that it better reflects, if it's closer to this one or that. Okay, that making sense? Hopefully that's making sense to you. Okay, I'm not going to go through this question too much more, but here's some notes, the things that you need for frequent free response questions. You need the numbers, you need to the proper decimal places, you need units, explain the meaning, including, fully explanation of the meaning, and units. Okay? All of that is required for a full point. Okay. For C, you're going to have to show... okay, so anyways, just make sure you have the explanation of what you've done, okay, the description of what you've done, and a word sentence, okay? Show your integrals even if you do it on the calculator, okay? Again, the point is not to go through this question too carefully, but all right. Okay, some other important notes, and I'm getting almost done this part. I've mentioned this already. You don't have to simplify arithmetic solutions, okay? So again, you don't have to reduce fractions. You don't have to, don't go the extra mile to make sure that everything is just right simplification-wise. Just stop when you just have your arithmetic explanation. You don't have to do much simplification, okay? Also, oh yeah, this was good too. I make you guys write the limit, right? Limit x approaches 0 for every line, right? She reiterated that. If you only write the limit for the first line and then it's equals and then something and there's no limits, when it actually is a limit, you lose points. So write the limit notation all the way through the questions, just like I've taught you, until the very end of the question when you actually substitute that value in or apply that limit, then you can just write without the limit notation. Okay. Another note here that I came away with, be sure that you state the hypotheses for theorems, for example. So if you're using the mean value theorem or something, you have to state the hypothesis that this function is continuous and differentiable over this interval. Therefore, the mean value theorem states that. Okay? So be clear that what you're using, the theorem, and that the hypotheses that are required for that theorem to be applied are mentioned and stated accurately. Okay? That's very important. All right, so that's kind of my tips. I just kind of wanted to go over, here, actually, no, there was a couple other pages here. So there were some questions that were sent ahead of time for this webinar that I took in. Please make sure you know the difference between an indefinite integral, which has to be followed by plus c, okay, the constant of integration, when you evaluate or when you simplify or apply the integral. And a definite integral is different because it has the actual limits of integration and the answer is just a number, okay? So please make sure you know the difference there between those two. Is there a certain way to show your work? We've talked about a lot of this, okay? We've talked about a lot of this, but you should always write the equation that you intend to solve. Make sure you have correct notation with your limits. Derivatives and integrals with all correct notation. They'll be looking for the proper limits and that you write everything. Don't forget your dx. Integral f of x, dx. Don't forget to write that, please. All right. Again, you don't have to write a novel for the free response questions here. Just be concise, and if you write too much and you contradict yourself, you'll lose marks. So if you say something right over here and then you're further explaining in a different flowery way and you say the opposite or something different down here, they don't match up, you don't get the point. So just be sure to be concise and be clear and make sure you answer the question. Just really quickly look over the question. I'm looking for the number of pounds of bananas. What do I have? Oh, geez, I have the rate here. What? Oh, I'm not answering the question. Okay, pounds. Make sure you're answering the question. Okay. All right. This one, okay. Yeah, I don't think I'm going to talk about this one here. Yeah, I don't think I'm going to talk about this. Okay. So in your studying, maybe I will just mention this. In your studying, write down what you tend to forget. Okay? And make sure you write that on a study sheet or write down what you tend to forget so that you see that with your eyes and are able to memorize that. If you make a mistake, understand and remember what you did wrong and review what to do right. So in your studying, if you're studying AP exams, you get a question wrong or whatever, figure out what you did wrong. Make sure you do it the right way so you can see yourself and feel yourself doing the question correctly. And in that way you're better to remember the right. If you just do something wrong and say, oh, I did that wrong, but I know where I went wrong, when it comes time to the exam, you might only remember what you did wrong. And then you won't remember if that was the right way or the wrong way, and you get confused. You can't afford that during the exam. Okay. All right. These are clips from the instructional videos on the AP Central website. So if you're taking the AP exam, you have login credentials. I'm going to get you to watch these videos, even though my videos are amazing. I'm going to get you to watch these videos because there's a little different perspective. The animation is great. It's very clear and concise. They use all the right terminology. And for you to review with these videos, I think is great as well. So I'm just going to mention that. Okay, so that's sort of my spiel about what I learned from this exam webinar and just other things that I've picked up over time. So online class right now, do you guys have any questions? Anything I can further clarify?